Alright, welcome back. So we're now working on problem 4, which is Brian is sending us messages from his university, and the messages, we don't want them to get lost along the way. So we want to make sure the messages don't have any errors. And so one way to do that is we also send extra information alongside the data that helps us check if there were any errors. So we're transmitting a 2-byte packet, and the first byte of that packet, the high byte, is the actual ASCII character you wanted to transmit, and the low byte of that packet represents the number of bits that are turned on in the data part of the packet. For example, here we've got the data packet OX4102. OX41 turns into 01000001 in binary, and there are two ones here, which means the checksum packet or the error checking packet should be 2, which it is. So we want to write a piece of code. It takes in a 16-bit packet, and if it's a valid packet, we return just the data part of it. So in this case, we return OX41. And if it's an invalid data packet, then we just return -1 to represent something went wrong in transmission. Okay? And the way we're going to do this is we're going to take the data packet and repetitively shift it to the right and extract the lowest bit and then add that to a counter. And we're going to continually do that until the data packet is 0, because if the data packet is 0, there can't be any more bits to add. All right? So we want to initialize everything first. So the first thing I'm going to do is I'm going to extract this part of the 16-bit packet and put it in a register. And the way I can do that is by using a logical shift right. By taking this number here and shifting it 8 places to the right, I'm basically going to get OX0041, because when I shift by 4 bits, that's the same as shifting by 1 hexadecimal digit. So logical shift right, R0 by 8, and store the result in R1. Okay, so I'll just put little comments along the side so I can keep track of what's going on. So R1 should now be 0041. And the next thing I'm going to do is I'm going to use a loop, and I'm going to keep shifting until R1 is now equal to 0. So I also probably want some counter. So I'm going to use R2 as my counter. I'm going to initialize it to 0. And R0 is going to count the number of bits that are high in R1. That's the goal of R2. And hopefully the value that's in R2 after the loop is finished should be the same as the bottom byte in R0. Okay? So I'll set up my loop. And so what I'm going to do in my loop, the first thing I should do is I should check if all the bits have been counted. And the way I can do that is I can check if R1 is 0. So I'm going to compare R1 to 0. And if it is, I'll branch to check valid, which would be another label that actually compares the number of bits I've counted with what the count should be. So we'll write this in a bit. We won't worry about that for now. So if the bit pattern, if the data byte, I beg your pardon, is 0, then we're done. Otherwise, there's possibly more bits to check. So what I will do is I will extract out the lowest bit by doing a logical AND. So if I AND R1 with a 1 and store it in R3, what that's going to do, it's going to take the bit pattern, so in this case R1 is equal to OX0041, which if you write that in binary is a stack of zeros at the start, 01000001. So when I do a logical AND with 1, I'm essentially extracting this bit here. So if the very least significant bit is a 1, then R3 will be 1. If the least significant bit is a 0, R3 will be 0. So essentially R3 just tells me what the least significant bit of R1 is. So our bit mask here is just 0B1 in binary, just the first bit. Now that I've extracted the first bit, if it's a 0 or a 1, I want to add it to my total so far. So I'm going to add R3 to R2, and then I branch back up to loop, and I do it all over again. Okay? Now I've got my check valid. So once we're in this part of the code, whoops, got the label twice over. Let's just remove that. There we go. So once we're at this label, R2 should contain the number of bits that were counted in the data packet, and then R0 contains this original value, and I want to extract out how many bits we think there should be in the data packet. So what I can do is I can do a logical AND, take R0, which contains OX4102, logical AND it with OXFF, and the end result is that R1 should contain just the lower byte. So R1 should contain OX0002. I then want to check if the quantity in R1 matches the number of bits I've counted in R2, right? That's the thing we're trying to check here. So I compare R2 to R1. If they're equal, it's a valid packet. And if they're not equal, it's an invalid packet. Okay? If it's a valid packet, so valid packet, whoops, then what did I want to return? I wanted to return just the OX41 by itself. So I can do that by logical right shifting R0 by 8, and the end result is that R0 will contain OX0041. And then I'm done, so I go to end. If it's an invalid packet, then I want to return -1 as a dummy value to represent something bad happened. So I'll just stick as a -1 in R0. There we go. And then branch to end. And then end is just an infinite loop. Technically, there's some branches here I don't need. This branch to end is unneeded, because after this command, I'll jump straight down to end. And this branch here is not needed, because if it was not valid, I jump to invalid. And if it was valid, I just fall into valid anyway. So you can sometimes skip instructions you don't need by realizing what will this code fall into if this branch would not occur. Alright, so we're done writing our code. We should run it and see if it works. So we'll save it, and then we'll build it, and then we'll use the debugger. We'll step through the code line by line to see what happens. Alright. So turn on the debugger. And we'll run through our code until we get to main, and then we'll step through and see what happens. So here we are in startup. Oh, and VS Code is being a little bit difficult today. That's okay, so we'll try the debugger again. Right, here we go. Alright, so we load our data packet into R0. So far so good. We right shift it down by 8 bits and store the results in R1. So R1 should contain OX41, which I will put this in hexadecimal so it's more useful. There we go. We've got just our data part of the packet, and we're going to reset our loop counter by putting a 0 in R2. Alright, so we first check, is the data packet 0? No, it's not. So if it's not, I take the result in R1 and I pick up the first bit and store it in R3. So maybe it would be more useful if we saw this in binary, so that way we can actually see the bits. Okay, so logical AND this whole number with a 1 and store the result in R3, which basically extracts the least significant bit. Because the least significant bit is a 1, we expect R3 to also be a 1, which it is. And then we add that to our loop count, to our bit counter, which is R2. So 0 plus 1 is 1. And then, whoops, I forgot to right shift R1 down each time I do it. Because each time I execute this instruction, I want to right shift this down by 1. So I'd better add that in. LSR R1 by 1. Okay. And so run the code again. Alright, open the debugger. Having a good think. There we go. Alright, so we'll skip that part we already just did. Alright, so do the compare. It's not 0. Do the logical AND. Add the 1 because I see a 1 bit. And then I want to shift this down. So I bump all the bits down by 1, and then I do it again. Is the data packet 0? Well, clearly not, because there's a 1 still left to count. So we don't branch. I pick the least significant bit out, which in this case is a 0. So R3 will be 0. And then 0 plus 1 is still 1. So we the bit counter doesn't change. I shift down again, shift, and then we do it again. And so this is going to spin in a loop, shifting down these bits, and each time we see a 1, we add the result to R2. So we'll just let this thing run, and then put a breakpoint here at check valid. So spins through. Oops. Alright, the break, you have to turn the debugger again when you modify breakpoints, but that's okay. So we can see that the bits are shifting down, and then we'll add 1 at the very end, because here the least significant bit is 1. And we get 2. Okay, so our loop, our data packet is now 0. So when I do the compare, I will jump to check is valid, and here we go. So I've counted that there are 2 bits total in OX41. I want to check if that matches the error part of the packet, which is the number 2, and it does, but we'd better verify that. So I take R0, I AND it with this constant to pick out the lower byte, and I store it in R1. So R1 should contain a 2, which it does. Again, it's hard to see because it's in binary, so we'll put it back in decimal. There we go. I want to check if R1 agrees with R2. In this case, it does. So we do the compare. If they weren't equal, jump to invalid packet, but we don't do that because it was valid. I take R0, I shift it down by 8 to extract the data, and then I go to the end, and we're done. So the end result is we verified the packet is indeed valid, and there's an OX41, which was the original data packet, left in R0. There's an exercise that might be useful if you pick something that isn't a valid data packet, so like this one here, and step through the code, and you'll see that the number of bits that you count in OX4A and the number of bits that you expect for, they don't